This is the first lab or the lecture for the SMD version, the SMD PCB I'm talking about. I hope everyone can hear me out, and I'm going to share my screen also. The circuit which we are today talking about is experiment number 7, and I have that circuit here also. I'm sharing my screen so it will be easy for so my screen is being shared, so I hope everyone can see my screen at present. Okay, the experiment we have over here is this, that you have actually I have done a little mistake. This should be experiment number 6, not experiment number 7. But anyway, sir, we'll change it afterwards. So this is experiment number 6, and this is exactly the very same circuit which we have done previously in experiment number 4, if you remember. That was the yellow dot matrix, and that was running through a high side transistor switch and a ULN2803 IC. And if you remember, the size of this PCB was approximately, it was a single layer PCB, and the size I asked you was something like 90 cross 90, and then I changed those designs, the limitations, to 100 cross 100, or maybe even 110 cross 100. Today we are again going to be doing the same thing, but the thing which we are actually going to enforce now is actually the SMD version. SMD means the surface mount devices, or surface mount device. Now, up till now, whatever PCB you have made, the transistors, the ICs, the resistances, the capacitors, and everything, they were actually through-hole devices, which means that there was a hole drilled in your PCB, and there was a pad, and then your component was actually going through that hole. So practically it was a through hole device. You were soldering it on the other side. Even if it was single layer or even if it was two layer, then it was going to be soldered either on the both sides or maybe one side from wherever that track is originating. Now SMD version actually came in 19 after 1980s, something at that time, where the task was actually to reduce the size of your, and nowadays I guess you are all familiar that nowadays everyone wants a slim mobile, everyone wants a smaller TV, everyone wants a smaller sleek laptop, everyone wants something very small, and it can actually have the smallest weight also. So then came actually some of the packaging, or some of the packaging of the ICs that were actually going to be very small. Today actually I am going to show you some resistances which are going to be very small. I am going to show you some capacitors, and then some regulators, some ICs. So circuit diagram which you are seeing at present is the very same. Nothing changed in the circuit diagram. The only thing that is a little missing from your experiment number 4, when you did this experiment through hole, was this, that there was dip switches. Now because when this PCB will be made, you would have done that PCB previously also, so practically dip switches will not be that much required. You already know, and maybe we will, that I will be testing this circuit through a microcontroller, so dip switches are not going to be required. So you can see very easily that dip switches and the pull down resistances or whatever, they were actually now abolished. So now, from now on, this experiment number 6, which is actually experiment number 7 written, that's my mistake, I will change it afterwards. So this task is to make it the smaller version, and for that purpose we are going to have the uh, ICs, resistances, or capacitance, or whatever is going to be used are SMD version. Now before I move on to the circuit diagram and explain you each and everything, as I've told you that SMD stands for surface mount device, and if you have seen this an LED up till now, you have seen that it was a through hole. I physically showed you also in the first or third lecture, I guess. An SMD LED is going to be soldered on the same layer. So if you are actually talking about something in a SMD, it's not going to be having a hole. So when it's not going to be a hole, it's actually going to be soldered on the top layer or maybe on the bottom layer, whatever it is, just like this one. So there is going to be an SMD. Now, when you are talking about an SMD, I hope everyone can hear me out. Please, anyone confirm me on this one. You are going to make this in one layer, beta. Bilal, if you are online, I guess you can handle this chat section over here. Now, when you are talking about the LED SMD versus the through hole, I'm just going to show you a simple picture, simple Google Images picture I just took from the yes, this was the picture. So if you are having something like this, you can, I guess, zoom in very carefully over here. This is an SMT PCB, and this is going to be SMT PCB versus the through hole technology, and I hope everyone can see this out very carefully. The right side picture, it has the through hole components. In fact, it has a little through hole components. Not all are through hole. Some ICs are SMD. You can easily point out in this one that this IC where a mouse or cursor is hovering, this is still an SMD. This is still an SMD. But if you see this variable resistor or this resistor over here or these two resistances over there, they are through hole. But if you see an SMD PCB, you are actually saying that there is actually there is no hole. But yes, if it's going to be a two layer PCB or maybe even a more layer PCB, we will talk about this more layer stuff in some later on classes. But just for now, there is actually practically no hole. But if you are going to have like 2 layer, 3 layer, or even like 14 layer PCB, then there are going to be vias, which means you can connect from one layer to the other layer through those vias or whatever. So the point over here is this, that SMD PCBs, they are very small, and I will show you a little picture of what we are actually trying to make today. This is a PCB which I have made over here, as you can see very carefully. The IC is there, and this is actually the bottom side, so don't worry on this one. Now, what you are seeing over here in front of you, where my mouse or cursor is hovering, this is that transistor which is going to be SOT89 packaging. I will show you just now later on, but the size is so small, and this packaging is also a transistor where my mouse is hovering at present. This is that same transistor 2N3904. Now this 2N3904 transistor is going to be so small that if you compare this with the normal 2N3904 which we have been using TO92 packaging, it's very difficult to even handle it, and the soldering is not very good in this PCB picture which I am showing you at present. So this is this transistor, this is that bigger transistor. This can handle actually 2 amperes of current, that's why it's a little larger. And then you have this IC over there, and then you can see over here the resistance. Now before I move on to the ICs and all that stuff, actually the first thing in this circuit diagram is actually the resistance. Now I told you in the previous classes also that the resistance over here is actually the rated value which is actually going to dissipate that heat when that resistance is going to be used. Now the resistance which you have used or which we have given you in your toolboxes now, which you have got it, it's actually a quarter watt resistance, and a quarter watt resistance means that it is approximately 0.25 watts. Now when you convert this into an SMD resistance, an SMD resistance is based on, I have already shared with you this resistance value details. They are also available on my website link I have given you. I have shared in the WhatsApp uh, group as well. So you can see now over here I have a lot amount of different resistance types. Their sizes are written. Now if you see the topmost one, that is 2512, the size is 6.30 into 3.10. Then you have a 2010 size. Now this is actually 2010 name given to it, and that is because if you very clearly see over there the size in inches, that is written as 0.20 into 0.10. Then you have 1812, then no, 2512, 2010 and 1812. They are very big sizes, and I think so practically they won't be even available very easily at Hall Road. But normally the resistances which you are going to get easily from Hall Road is actually going to be 1812, 1210, 1206, 0805 and 0603. Now, those of you, now this is actually just giving you the idea that SMD resistances comes in how many different sizes. Now, how these sizes actually practically show you in front of you. Now, this is a 0402 SMD resistance. This is a normal adult finger, and you can see very tiny bit of resistance over there. So, and even the pixelated image is over there. I don't have the actual good quality image, in fact. So this is a 0402, and for a 0402, if you want to do a comparison, this is that comparison over there. You can see the 0402 that is having a size of 1 cross 0.5. This is the physical size. Certainly the pad is going to be a little larger so that you can solder it. Now this resistance, how they are actually named over there, the 100 and all that, we will talk about that in a later one over there, but not now, because they are actually again having, they're not going to have any color codes over there that you have done in circuit analysis up till now. Here the coding is going to be based upon some nomenclature, that this is going to be a 100, so this is actually going to be a 10 ohm or 100 ohm resistance, and if it is written 103, then that is actually going to be a 1 kilo ohm resistance over there, and we will talk about this later on. Now, so you can see 0402, which is just at the fingertip over there, and that is just 1 mm cross 0.5 mm. Now 0.5 mm is the thickness of this, or you can call the width of this resistance. And if you remember the PCBs you have been making up till now, I have been asking you, the track size was 0.5 or 0.6. In fact, 0.5 was never asked, 0.6 or 0.7 was the value I asked you. So you can see very easily that a 0402 resistance is going to be so small that you can't handle it with your bare hands. You will require some forceps or tweezers so to handle this type of a resistance. And if I open this picture in front of you, this PCB is soldered over here. It's the same PCB which you have to actually make for this experiment number 6 over here. And this resistance over here which you are seeing over here, on which my mouse is hovering, is actually 1210. So you can see this is 1210, and this resistance over here is 1206. So this whole PCB which you are making over here is dependent upon the size. So you can see wherever there is 1210, there's a little bit size larger, and that is completely okay, because you know 1210 is having a size in millimeters of 3.2 cross 2.6, and 1206 has a size of 3 cross 1.5. Now the size variation, that actually gives us a very important concept, that the power ratings are different. Now if you are talking about a 1206, then it has a 1 by 8th watt, which means it's not quarter watt, it's approximately 1 by 8th of a watt, so 0.125 watts. And if you are having 1210 size SMD, then you are actually having a 0.25 watt. So the normal resistance which you have been using up till now in your PCB designs up till now, or maybe on your breadboard or somewhere else, that was 1210 size. So in SMD, that something looks like this value. Maybe in the hardware session we'll do most probably in this weekend. I will show you all those resistances, maybe if I can show you on some camera. In fact, you have the pictures over here in front of you. You can see this picture. This is a 1210 and this is a 1206 over there. And your circuit diagram, which is for today, is actually having all of those SMD sizes equal to 1206 and 1210. Now, I will not go specifically to each and every SMD over here, but if you very closely see this one diagram, this resistance of 4.7 kilo ohms is 1206. And if I show you this diagram again over here, this resistance over here is 3.9k. So I have actually not the value of that resistance was not available with me of 4.7, so I've used that 3.9 kilo ohms over there, and then there is a 470 ohm resistance, and I can show that again over here. So this is actually, you can see one is written as 3901, other one is written as in fact where is the 470 ohm resistance value? Okay, this is that 471. So this is actually that 4.7k, and then this is the 390 ohms over here. So the values are there and the circuit diagram is here. But the point to notice over here is this, that the resistance, this one, which is actually a 10 ohm resistance, and then there is a 1210 SMD, and the resistance which is going towards the SMD ULN2803 IC, they are 1210. Now why they are 1210? Because the circuit is going to have the maximum current flowing through this resistance, through this transistor, and then through this yellow dot matrix, and then inside this IC, and then certainly towards the ground, which is connected to a block connector. So this resistance and this resistance, you can see they are at 1210 SMD. So even if there is going to be like something 10 milliamperes or 7 milliamperes or maybe 100 milliamperes, not 100 actually, but maybe 20-30 milliamperes of current flowing over there, you can do the I square R calculation, the power resistance calculation, depending upon whatever value you are using. 10 to 33 ohms over here, 1210 SMD, and then this is a 1210. The rest of this one, 1206, 1206, 1206, they all are 1206 SMDs resistances. And I have given you the picture image of 1206 versus 1210 also. This is the footprint. I will show you on the LTM also just now. This is the 1206 SMD resistance, and you can find it. This library is already available inside your LTM. You just have to select chip underscore resistor underscore M. It's already available in that zip file that was given initially to you. That was PCB footprints underscore 110209. You unzipped it and then added inside your LTM library. So there is always going to be a chip underscore resistance underscore M, that PCB library. Now one thing very important, chip underscore resistor underscore L is also there, N is also there. Now I leave it up to you, find out the difference if it is chip underscore resistance underscore L, if it is underscore M, it is underscore N. Now there is just a little bit size difference between L, M and N, but where they are used, anyone feel free to answer it after this class. Now you can see the difference, 1206 SMD resistance and 1210 SMD resistance. You can see the body is 3.2 cross 1.6, which is 1206. And if you are talking about 1210, this is 3.2 into 2.5. So the thickness is a little large. The length is almost the very same. So you can see the 3.2 cross 2.5. And if you see this one in the SMD resistance charts over here, in fact not this one, sorry. So if you are talking about this one, in fact not even this one, I'm talking about this one. So 1206, this is 3.2 into 2.6, and this is 3 into 1.5. So these are the same sizes which are written over here on this PCB over here, sorry, in this one. So this is 3.2 into 1.6 and 3.2 into 2.5. So you can easily find out these libraries inside chip underscore resistance underscore M over here, or chip underscore resistance underscore L, or whatever variable you want to actually use over there. Now this is the resistance that are used over there, so you have to follow this nomenclature. The next thing which is very, very important over here is the transistors. Now the transistors are BC869. Now previously, if you remember, this transistor was 2SA683 or 684, whatever you are actually available with you. Now that was a through hole. Here you require a SMD package, so I have selected BC869, easily available, and the data sheet you can easily get it on. I have that data sheet with me, and if I click this data sheet over here and I open this data sheet in front of you, this is the BC869. This is a PNP medium power transistor. Now the only problem over here is it's just 20 volts. Okay, it's a PNP medium power transistor, 20 volts, 1 ampere over here. And if you remember 2SA684, it was approximately like 40 amperes, and then 683 was like a 60 and 40 was the value over there. Now this transistor, as you can see, it's approximately, again the negative value suggests that it's actually going to be a PNP, and it can actually have a 1 ampere current. 1 ampere is sufficient for us because we are only having a simple one. Now if you are seeing this one, BC869 simple one is available in SOT89 packaging. Again, this is SOT89 packaging, and if you want to see this 89 packaging, you can see from the front it looks like this, just like the picture I have shown you just now. This was that same picture, and if I can just zoom in a little bit over there, this is actually soldered from this side also, and these three sides also, this 3 pin. So just like this PCB, it has this center back over here. This is placed on the PCB. It is not going in any of the holes. Please remember, all of this PCB which you are seeing at present, it does not have any holes apart from any jumper wires. Okay, this PCB does not have any holes apart from any of the jumper wires available over there. Everything is there on the surface. It's connected. If you see this transistor, this is connected over here in this configuration. This is SOT89 packaging connected over here, and you can see from very easily over here that which pin. This is pin number 1 2 3. So this is 1 2 3. So this is emitter here, collector here, base here, and this is from the front. So this is actually the PCB when you are seeing this PCB from here. So this is that emitter, collector and base. So I hope I've not done it. Yes, emitter, collector, base. So if you are seeing this one over here in this direction, so this is emitter, this is collector, this is base. From where the mouse is, emitter, collector and base. So this is emitter, and the center pin is connected with the back of it. So which is the back over there? This is that SOT89 packaging. And for those who are actually again having a little bit what is SOT89 packaging, and SOT89 packaging is actually this packaging. As you can see, this is this SOT89. Actually the picture scanned is not very good over here, so I have shown you over here. So this is a surface mount device. You can see the back side of it. You can see the back. This is connected with the center one from the back. So this is placed on a horizontal PCB on the horizontal surface, and this is going to be connected just like the same way over here as you have done over here. So this is SOT89 packaging over here. Now coming to the next over here, the transistors, how you are going to find out this BC869. The picture is something going to be like this, as you already have seen, and this is an SOT89, and this is going to be available in SOT89_L library. Now here one thing very important, it can be L, it can be M, it can be N. Okay, I'm leaving it up to you to find out the reason or which you want to use. You want to use L, you want to use M, you want to use N, it's totally up to you, but the description is there. SOT89, 3 leads, body 4.5 into 2.5 2.4 mm, and pitch is approximately 1.5, I guess. And if you want to confirm this picture, you will go in your BC869, and I will see over here. You can see this is the printed circuit board, the same PCB done over here. In fact, I will try to go towards the, yes, this one is the SOT89 over here. You can see the pin spacing. You can see, I hope everyone has an idea how to read this one. If you are seeing this is pin number 1, pin number 2, so between pin number 1 and pin number 2, that this spacing is E1. What is E1? That is 1.5, and this is the same value that I have just shown you over here. This is 1.5. You can go to SOT89_L.PCB library, and for those who are actually a little so I can just double click it. So this is actually the lead span. So this is that same 1.5 mm, pitch 2.4 pitch 1.5 mm, sorry, body 4.5 or 2.4. It's a 3 lead SOT89 packaging. So this is a transistor SOT89. This is the same PCB which you have seen physically just now. I have shared you the pictures also on the website. They are also shared over there. So this means that in place of 2SA683, you are going to use BC869. The data sheet, you can easily find out the data sheet from Google. I've not given it. Please make a habit of actually having the data sheets downloaded yourself. So this is a BC869. It's again a PNP medium power transistor because it's just having a 20 volts. So this is 1 ampere, and the pin configuration, please be very careful, because when you are going to place this PCB or place this, sorry, this component on the PCB, this has to go on the bottom layer. This is a very important thing over there. When you are actually going to, supposingly I have this PCB over here and I want to go in that library, I will go to place components. Let me just select on. This will take some time actually because it goes on with all the database. I still have approximately like a 6 or 8 MBs of. So I require SOT89. I'm searching for SOT89. Okay, so SOP is there, SOT89. Beta, please write down in the conversation window. I will read it from there. Don't speak. Please mute yourself. SOT89. So you can see now I have this library over here, SOT89, and I have a 3 lead 1.5. I don't need to get SOT18. In fact, SOT89L, I am going to take it from here. I'm not going to take the 5 lead and the other one. So SOT89L, and I click OK. Now you can see this is play. Okay, my screen is not being shared. Why? But my screen is shared. Okay, again, let me just do the sharing again. Don't worry. It's recorded. Can you now see it, beta? Ji beta, please confirm.
Yes, sir. Yes, sir.
Actually, this is a problem from MS Teams, I guess. So sorry for that. Recording is done, so I just hope so. What I did just now, in fact, what I just now is this place component, and I went in the SOT89_L, and I showed you that SOT89L is there, M is there, N is there. In fact, for every SMD library, there are 3 versions, L, M, and N. Find out what each one of them does. But for now, you can use L or M. It's totally up to you. I have used the L version or M version. There's not that much difference, but try to find out the difference yourself. So I've selected SOT89L over here, and I just clicked OK, and I have now the package. Now, when you have this package, and if I zoom in this one, this packaging over here, this is placed on the top layer. So I wanted the PCB to be on the bottom layer. It's going to be a single layer PCB. Okay? It's not going to be a 2-layer PCB because this is SMD and I want to reduce the size. So what I will do, if I want to convert this blue one into the black, the red color one into the blue color one, so I will double click this one, and on here where there is a layer written, I will change this to bottom layer. So what will happen when I will do this, you can see now this has changed its orientation. Now this is placed upside down. Okay, this is placed upside down. This is very important to learn over here, that this PCB, if this component, when this is going to be placed over here just like this, if you can see this very carefully over here. Now if you are seeing this one, you have to identify which one is emitter, collector, and base. So if I go back on my data sheet, the center one is not going to be changed because that's the center pin, so that certainly is the collector. The other thing is 1 and 2. Now when you are seeing this data sheet, this is from the front side. So when this side will change and the PCB is going to be made from the bottom layer, because this is a bottom layer PCB, you are going to flip it. So one will go on the other side, so which means that when this is going to be placed on the bottom layer, this one 3 is going to be still base, but this 3 will be on this side when you are going to take it visible from here. So when I have this PCB like this over here, also this component like this one is the center pin is certainly the collector. Okay, just like it is written over there. Then I have the emitter over here, which is on this side, but when I have seen it over there, this one would be emitter. Where I have selected this one would be emitter, because this component is placed on the bottom side of the PCB. Here's one thing very important. You can see this PCB, this is the bottom side of the PCB. And if I want to show you this same PCB from the front side, this is something like this. What is on the front side? Only a male header, 8 pins, a block connector, and a yellow dot matrix. Nothing special. But when I have this on the bottom side, so you can see this is actually the unsoldered PCB over here. So you can see now it is soldered on the bottom side. So on the front side, it's having nothing over there. So this is the side over here on which the components are soldered, and I have placed them over there. So now this is the emitter, this one is the collector, this one is the base. And when I will turn it like this, certainly that will change. This one will be emitter, this one will be collector, this one will be base. So take very much care that you don't have it. But when you are going to use it on the top layer like this, then it will be the very same, just like as it is shown over here. So this will be emitter, collector, base. So when I will have it, this will be emitter, this will be collector, this will be base. So be very careful when selecting SMD components. Wherever you are actually going to place those SMD components, that's a very, very important factor over there. So this is going to be SOT89 packaging for BC869. The other transistor which is inside this over there is actually the 2N3904. Now 2N3904 is available in SMD, but the name is written as MMBT3904 and the packaging is SOT23. Now, what is SOT23? This is actually a packaging much smaller than this BC869, as you have seen physically also. In fact, let me just show you the MMBT. This is the MMBT 2N3904. You can see the transistor, and on this one there is going to be written 1A, as you can see over here. And if I open the data sheet of this one, let me open the data sheet also over here. So this is MMBT 3904. It is available from many manufacturers, maybe Fairchild, maybe any other company. I have the center one. So the one which is available at Hall Road very easily. It's not that expensive, even it's just like maybe like 2 rupees or maybe like 1.5 rupees per. These are like 6 months old rate, but I don't know the present ones. So this is MMBT 3904, and if you are seeing it from the front, you have seen it very carefully. This is C, this is B, this is E. And again, when you want to find it out, you are again going to find it out. If you go to the place, you go to the components, and here this time I want to find out SOT23. So again, you can see SOT23. I have 3 libraries, L, M, and N. So I have L over here, and I am going to select maybe SOT. I want to actually select a 3 lead and a simple one, which is going to have in fact, let me just confirm it out. I have to select SOT233, this one, the last one, which is actually having this one. So when I will select this one, click OK, and I have this one. So now if you see this very carefully, this transistor which is placed on the top layer, this transistor is placed on the bottom layer. So this one, you want to change it to the bottom, change this layer configuration, this will be changed opposite. You can see it again automatically mirrors itself. So this one is the 2N3904 replacement, which is actually the same transistor but with a different tag name. And this transistor physically is so small. If I can show you this transistor, this is this transistor where my mouse is hovering. This one is that transistor. So this is the now if I open the data sheet over there, certainly the center pin on the top is the collector, this one is base, this one is emitter. But again, when I'm going to make this transistor on the bottom layer, the base side will move on the other side and the other one. So if I have this transistor like this placed over there, from the data sheet I know the center one is collector. That's not going to change even if I flip it horizontal or vertical, whatever. And then I have base on the left side and emitter on the right side. But when I'm seeing it over there, emitter will be actually here and the base will be on this side over here. So be very careful when you are actually placing the components. And as you can see very carefully, because you know the base is going to be connected with the resistance and then with the male header. As you can see the circuit diagram over here, what is done, this transistor, the emitter is connected with the ground, and then there is a 1 kilo ohm resistance which is in SMD packaging, and then it is going to be connected with the male header. So you can see in this picture diagram very carefully that this is the base over here, from where the base is, and you can see I have written it B1 net, and then this B1 net is connected with a 1206 resistance, and then this is connected with the other part of the resistance, and then there is a 8-pin male header by which it is running, and then this is the emitter. So this is emitter, all of the emitters are connected, and the 0.65 width is at least required for this PCB. Please remain to 0.6 or 0.65, don't go beyond that, less than this, otherwise it's going to be very difficult for you to actually make it. So this is the transistors over there. The last thing which is remaining in this whole PCB circuit diagram is actually the yellow dot matrix will remain the same. There is no SMD version of that one coming up. So you are going to use the same library which we have used previously. The next thing is the ULN2803 IC. So if I open the data sheet of your ULN2803, which is SMD version, here you can see this is a dip version which we have normally used, and we have seen it. This was now this time you are going to actually use the SMD version. The pin configuration is going to remain the same. It's again going to be an 18 pin. but this time the size is going to be so small. If I just scroll down to the bottom of this PCB, this is the SOIC packaging. You can see from pin number 1 to 9 and then 10 to 8, the same sequence of actually having the pin numbers from 1 to 9 and then going on towards the opposite side in anti-clockwise to 10 to 18. So this is SOIC packaging, and let me show you the ULN2803 SMD library which you have to use. This is an SOIC packaging 18 pin, and you have to use it SOIC underscore 127P underscore L library, and that will be, if I just show you without going into the place section, this is this IC over here, and if I just place it over here for your, and I want to have it supposedly on the top layer, then this will be something like this. I can rotate it over there. This is pin number 1 which I have selected over here. This is pin number 9, and then this is pin number 10 to pin number 18. But again, be very careful when you are going to make it on the bottom layer like this. This is going to be different. Now this time when you are, because this you are seeing it from the other side of the PCB. So this is pin number 1, okay, where the dot is there, and then you are moving here towards 9, then this is 10, and then this is 18. I'm again repeating, this is pin number 1 from where the dot is there, because if you remember the PCB, the dot is there, the pin area. So this is 1 to 9 and then 10 to 18. So when you are having it like this, so this is pin number 1, 2, 3, 4 to 9, and then 10, 11, 12 to 18. So ULN2803, the pin configuration will remain the very same, just like you have done it from pin number 1 to 9. So pin number 1 to 8, they are going to be connected with the resistances, and those resistances are going to be connected with the the yellow dot matrices over there, just like this one. And here you are going to have no dip switch. You have directly 1, 2, 3, 4, 5, 6, 7, 8, just a male header connected over there. And if I can show you the pictures very carefully, and if I just zoom out in this one, and you can see what I have done over here, this is the same packaging, and this is pin number 1, 2, 3, 4, 5, 6, 7, 8, and then the next one is ground. So this, you can see I have used a fill area so that it can handle a large amount of current, and then the other side it's connected with 1, 2, 3, 4, 5, 6, 7, 8. Now you can see very carefully that I have placed this dot matrix on top layer. It certainly is going to come on the top layer, and the resistances, they are actually going to be placed on the bottom layer, because it's going to be a single layer SMD. Okay, this experiment which you are doing is a single layer SMD. So this is 1, 2, 3, 4, 8 resistances, and you can see they are connected over here, and this male header is also connected on the other side. So there is no problem, because on the other side of that PCB, the male header is actually going to come out. So if I show you the pictures actually of this one, this is the male header. You can see very carefully, this is that ULN2803. You can see the name also subscribed on this one. This is ULN2803AG. The soldering is also done, and this is the 8-pin male header connected over here. Now it will be a little difficult to actually solder it from this side, but hopefully I will show you on that one also. So no issues over here for having this PCB soldered. All of it is soldered. The only thing problematic is this, that since this is a single layer PCB, you are going to have some jumper wires. You can see the jumper wires 1, 2, 3, 4, 5. So you are actually going to use those jumper wires just like you have done in your previous PCBs. And this one, this is actually the other picture, and this is the top view and the other view over here. This is actually the PCB when it was made physically at that time, and you can see these holes are just for the jumper wire. So you can see this wire is connected with this one, this is connected with this one is connected with that one. So some crisscrossing, not the very best of the PCBs as far as my standard is concerned, but still a very good PCB overall. The only thing left now in this experiment which I have to explain over here is this, that the input section. Now in this PCB design which you are seeing at present, I don't have any power supply section. I just have connected a block connector with 5 volts and ground. This is the 5 volt line, this is the ground line, and you can see the 5 volt line, it's thick over here, and then there is no regulator over here. This time you are going to add a regulator, and that regulator, you are not going to use the same 7805 that was the common. Now you have to use 78M05. Okay, 78M05, and I have given it on your link also over there. So please, I will just show you. I have shared the SM105 datasheet also, and the footprint also. You can download this footprint and you can use the footprint over here. which picture is shown over here in this picture. So you can see, and what is a 78M05? I will just show you just now. A 78M05 is something like this picture, a D pack or D2 pack. This is actually the configuration. It's actually SMD. You have been using this one up till now, TO220. This one is DPAC value, and the pin configuration is very simple, as I have shown you in this one. This is the input, this one is the output, the center pin, which is actually not here. So then this component is going to be placed on the SMD over there, or the PCB. This is actually going to look like this. Let me show you when it is placed on the PCB. So this is going to be placed on the PCB like this. This is actually the top side and the back side. So you can see this is the input, this is the output, and then the back side, this is actually the ground. So the ground is actually going to handle a lot amount of current. So the front side is actually going to look like this, 78M05. You can see the legs are bended. So this is actually going to be soldered on the same layer. So your circuit diagram is actually going to be having just a block connector, from here the input, and then there is going to be the ground connected, and then the output. So this is actually the physical shape of that 78M05, and the output, again, you are now going to connect a transistor and then an LED and a resistance. But here again they both are going to be SMDs, which means that the capacitor is going to be a 1210 SMD. This is actually a mistake over here, SMD, I have missed D over there. So this is a 1210 SMD size, 10 microfarad. And for those who have an idea, if SMD capacitances are, let me just show you, 1210, this is the SMD capacitor, easily available. Again, the packaging size is just like the resistances. So 1210 or either 126. You can see this is 1210 SMD capacitance. The size is very, very small. When we will do this practical soldering, I will show you all of these capacitors physically also. So this is 1210 capacitor, 10 microfarad, easily available at Hall Road, I guess, not that difficult. And then the resistance, which is going to be 1210. You can use 1206 here also, but just as a precaution, I'm using 1210 because the power rating is not that much important. Ji beta, Ji Bilal.
The screen stuck over here.
Again.
Yes, sir.
Okay. Yeah. Actually, this is coming from the. Actually, this is a MS Teams issue, I guess. Not very. So I hope everyone can see this. Bilal, I hope.
Yes, sir.
Okay. Okay, so back to this circuit diagram over here. As I have told you, you have to use an SMD capacitor over here, which is actually going to be 10 microfarad or maybe 47 microfarad, but 10 microfarad is enough for this per PCB because the current is not that big. And then you have a 330 ohm 1210 SMD, and then the SMDs are also going to be 1206 SMD. So SMDs are also going to be in the same shape or whatever. If I was talking about this capacitors previously, so a 1210 SMD capacitor is something like this. And if you want to actually see an SMD LED, it's actually the size is the very same. So this is something like this. So 1210 SMD is something, let me just find it out. Actually 1210 SMD, it's not available over here. SMD LED size 1210. In fact, you can use a 1206 very easily. I hope so. I have written 1206. Yes, I have written 1206. 1206 sizes are the most used one. So this is actually an LED. So you can see very carefully in this one. I hope everyone can see this house. 1206 is this much size. Where my mouse pointer is it? And because this is just going to be 3.2 into 2.5 something, in fact 3.2 into 1.6 actually, and then you have a 0402, 0406, 06 and 0804. These are very, very small sizes. Hopefully in this lab I'm not going to force you to use less than 0804 or 1206. So only 1206 SMD LED, it can be of green color or red color, whatever, that can be done. In fact, I will share you some projects from the last year. They have used 1206 and 1210 size very carefully, and they have made some very good PCBs up till now. So this is the PCB circuit diagram for today, and as you can see in this circuit diagram, dip switches are not there. In fact, there is even no need of actually having a pull down resistance or something. So I expect this PCB, including this over here, to be as small as possible. So now the one important point, I'm going to have the second session of this lecture most probably on Saturday, but for that purpose, whoever designs this PCB first, and maybe you can give it to me as a, if you have a size less than 80 cross 80 maybe, or 90 cross 90 is some benchmark, you can make it. So when you have that PCB made and you can do it, then maybe I will solder a PCB. In fact, I will do the soldering first of all of a through hole PCB. So I will do the PCB soldering of, I guess Mr. Ateep PCB is there with me. So hopefully if you all can buy components for experiment number 2 and experiment number 3 from online, preferably online, it's totally up to you. I have given you the links on the link over here. I have given every detail of every experiment that is required over here. The yellow area means they have been already provided inside your toolbox, which you have got it, and then the blue color ones which you have to get yourself. So each and everything is written over there, how many female header strips you require, male header strips, whatever I see. This is for experiment number 2 and experiment number 3, and then experiment number 4, and then experiment number 5 over here. I have not yet added the SMD experiment, this one experiment number 6 over here. I will do it afterwards. And those who have got 8 or 9 plus marks in experiment number 2, remember again, those who have got more than 8 or 9 marks in experiment number 2, please, Sir Bilal will be sharing a link with you on which all of those students who are allowed to order their PCB are shared over there. One thing very important, since you have been made inside groups and those groups are working from one Lahori person and the other one is non-Lahori. I know there are some other students which both are Lahori, but the one who has the toolbox now, okay, they are actually going to make experiment number 2, experiment number 3, experiment number 4, and experiment number 5. So these 4 PCBs are going to be made by that person who has the toolbox now. Then you will return this toolbox and it will be given on to the next member of your group, whoever is that person, a non-Lahori or a Lahori, whoever that, and then we are going to ask that person to do experiment number 6, 7, and 8. Okay, those are going to be SMD PCBs, so a little bit less number, 3 there, 4 here, so they are going to be total 7 PCBs you are going to make over there. And I have given this one. I have shared the order equipment links also on this one. This is link number 1, 2, 3, and 4. These are 4 different shops at Hall Road. If you want to use this WhatsApp number, the IC shop is the most oldest shop at Hall Road. If you want to use it, it's totally up to you. I have had a talk, I have a word with him, Mr. Gadamfar. He had this WhatsApp number. Students can directly do their orders on this WhatsApp number, and they can have the cash on delivery also over there. In fact, if you want to use the Hall Road or Mega eShop over there, it's also available for you. You can do it over there. But if you want to go in person to Hall Road, you are also allowed to do that. But during this pandemic, I will prefer that you do it online so that it does not create any problem for you and you don't contract any virus. So this order equipment, you can do it from all of these 4 links, or if you have any other link, you are feel free to do that. No binding from my side on this one. As far as the PCBs are concerned, I have given you these 2 links. If anyone has any other link, please kindly share with me also. This is epcb.pk and this is Al Jalil PCB Hall Road. I have given their number also. I guess EPCB phone number is also there. But I guess one thing good about EPCB, they have made this I guess link over here. I talked to them. So you can just, I guess, yes, over here you can get your name, address, and everything, which material you want to make, what are the size or dimensions, and you can upload your file over here and you can order it. And I guess we can contact you very carefully over there. Otherwise, if you want to go towards the Al Jalil or Mukarram PCB, maybe you will have to collect physically from him at Hall Road. But for those who cannot do it, you can go towards EPCB. They are actually providing in just like 100 or 150 rupees delivery in Lahore. So these are the contact numbers and emails. One thing very important, I'm not asking you to go for the fiberglass and solder masking, but if you are not going to be a very good solder person, so please kindly go for fiberglass and solder masking. By solder masking, I mean that green and red or yellow color of masking, which I have showed you in my WhatsApp group also. But yes, certainly it will be a little expensive, maybe 100 or 200 rupees more if you are using a solder masking, and if you are using a fiberglass, it's a little better. The backlight is going to be a black color sheet, and then it is going to be, so please kindly order experiment number 2 and experiment number 3 PCBs first, so just to save that transportation charges, or if you want to collect it or you want to get it from any of the online. So kindly order experiment number 2 and experiment number 3 combinedly, or maybe in the same order, and then you can get that PCB. And hopefully on Saturday, hopefully by Saturday, some of you will have those PCBs with you, because even if it is Al Jalil or maybe EPCB, they are still going to take like 1 or 2 days, at least 2 days, I guess, at least 1 or 2 days for you to have the PCB ready with you with drilled hole, so that you can start soldering, because you have the toolboxes over there. You will get the link, or sorry, you will get this items over here. I would prefer that you buy experiment number 2 and experiment number 3. Two experiment items, whatever are required, are in blue color. They are provided, you get them, and your PCBs are also ready, and then you can actually start soldering it at your home. Since you have been given all those toolboxes, soldering wire has been given and everything has been given over there, so you can use this Al Jalil PCB at Hall Road or just EPCB over here. And coming on to the experiment again over there, this is experiment number 6. I will correct this one later on. Any questions from the audience, please feel free to ask over here. Ji beta, I've shared these links very carefully over here, and these are the equipment required. I'm again sharing this one over here in the chat window over here, and actually this is the epcb.pk. The email address is also there, so you can use any of them if you want to use it, or you want to use that Al Jalil PCB. They have this PCB actually. Gee, any questions with this one?